See, in this question, this is the question based on AM transmitter. We'll use two formulas. One is PT is equal to PC into 1 plus m square divided by 2. Okay? Where PT is the total power, PC is the power for the carrier signal, M stands for modulation. Next, they have given the two modulation. So for that we need to calculate the total modulation. For that formula is root of m1 ka square plus m2 ka square. Okay, two modulation, one of the modulation is m1. 40% means we can consider it as 0.4 and 60% means we can consider at 0.6. Correct? Okay, now they said for if the modulation index is 0.5, means if this is the modulation, that is 0.5 ka square multiplied by 2, and then AM transmitter radiates power, total power they have given, that is 10.125 is equal to PC. So can we get the value for PC from here? Calculate the value of PC. Then similarly we need to use this formula again, that is total power. PT is equal to PC 1 plus MT square by 2. First calculate the value for PC over here. After solving you will get PC is equal to 9 kilowatt. Now we can substitute the value of PC over here because they are asking us the total power, means they are asking the PT. So PC is 9, 1 plus, and modulation index we need to calculate दोनों का combination. So that would be 0.4 ka square plus 0.6 ka square, that is 0.72, right? So that will be 0.72 ka square divided by 2. Now solve it, that will be your total power which they have asked in the question. So again, this is also the important question based on AM. AM stands for amplitude modulation, right? They said the antenna current for of an AM transmitter is 8 ampere when only carrier is transmitted. Okay, so we can consider I total is equal to I carrier multiplied by root of 1 plus m square by 2, where m is the modulation index, right? So this is the formula we'll use. They said it increases to 8.93 ampere when carrier is modulated by a single sine wave. Find the percentage modulation, determine the antenna current when the depth of modulation changes to 0.8, right? So first we need to calculate the percentage modulation. Basically we need to calculate m value, right? M is equal to, we need to calculate. Now see, I total is how much? 8 ampere, right? And I carrier is how much? That is 8.93 ampere. So after substituting the value, can we get the value for M, the modulation index? Tell me. Sorry, मैंने उल्टा बोल दिया. I total 8.93. I total ज़्यादा होगी ना? And I carrier is 8. Okay, do it according to that and tell me the value for modulation index. So after calculating you will get modulation as 0.708, right? Now see, they are asking the percentage modulation, so we need to convert it into percentage, so multiplied by 100, right? So it would be 70.8 percentage, correct? So percentage modulation, we get it. Now they are asking determine the antenna current, means they are asking the total current. Now the modulation value is 0.8. So we'll use the same formula, that is I total is equal to I carrier multiplied by root of 1 plus m square by 2. Now I total we need to calculate. I carrier they have given, that is 8 ampere, right? Multiplied by, now they have changed the condition that modulation changes to 0.8. So now the modulation value is 0.8 ka square divided by 2. Now calculate it, then you will get I total. Tell me. So we'll get the total antenna current is 4.525 ampere. Okay, understood? Next question, again this is also the important one. They said when the modulation percentage is 75. This is also based on AM. Modulation percentage is 75 means M is equal to 75%. Correct? AM transmitter produces 10 kilowatt means power is how much? PT, total power. In the previous question we have done na? AM transmitter, that was the total power. In this also AM transmitter, that is the total power. So whenever they said AM transmitter produces, that means this is the total power they have given. 10 kilowatt means 10,000 watt, right? How much of this is the carrier power? Carrier power means we need to calculate the value for PC, correct? We just have done the formula, that is PT is equal to PC 1 plus M square divided by 2, correct? So from that we know PT, we know modulation. So can we get PC? Solve it and then tell me the value. So next PC की value you will get it जो भी आएगी. What would be the percentage power saving? hmm? Now after solving it, we'll get this value, correct? Now see, after this, what they have asked in question, they ask what would be the percentage power saving, right? If the carrier and one of the sidebands were suppressed before transmission took place. So remember, I told you there are two types of sideband. One is USB and one is LSB, right? USB stands for upper sideband and LSB stands for lower side band, correct? So it would be PUSB power at upper side band would be equal to PLSB power at lower side band would be equal to PT minus PC. Okay, so total power they have mentioned in the question, that is 10 kilowatt, that would be 10,000 watt. PC we have calculated here, that is 7804 watt, 7804 watt, and divided by, this is the formula, you can note it down also. So after solving it, can you tell me what the value you got it for? So after solving it, you will get sideband value as 1098 watts. Now back to the question, what they have said. They said what would be the percentage power saving, right? If the carrier of one of the suppressed band took place. So formula for that percentage power saving is will have PC plus PUSB divided by total power. You can note down this formula. Actually there are many formulas related to the AM and FM, and every formula you need to remember because none of the formula is mentioned in the handbook. Okay, you have PC, right? You have PUSB, you are just calculated, and you have total power. Just substitute the value 0.8902 multiplied by 100 because they are asking for the percentage, so it would be 89%. Okay, Now see, next is the question based on FM system. In an FM system, when the audio frequency is 500 hertz, so they have mentioned FM is equal to 500 hertz. Okay, modulating voltage is 2.5. मतलब modulating voltage is like this ki, and its amplitude is how much? It goes up to 2.5, so its amplitude is 2.5, so AM is equal to 2.5. The deviation produced is 5 kilohertz, means change in frequency is 5 kilohertz, right? So it would be 5 into 10 raised to power 3 hertz. Understood? They have set frequencies of F, modulating frequency, modulating voltage means the amplitude. Now they said, now we know the formula. Let's see which formulas will used in this question. First formula is beta, that is equal to, basically first formula is modulation index, that is beta is equal to delta F divided by FM. In the FM modulation frequency modulation, they have mentioned modulation index by beta. Okay, another formula which we are going to use in this, that is KF is equal to delta F by AM. Okay, so delta F for modulation index, it is frequency, and for the KF is the constant, by that is AM. Okay, so we need to use these two formulas only in this question. Let's see how. For the very first case, we can calculate the value for beta. Beta is how much? Delta F divided by FM. We know delta F, we know FM. Tell me the value for beta. So that would be 5 into 10 raised to power 3 divided by 510 is the answer. Now they said in the next part, now if the modulating voltage is now increased to 7.5. Earlier the modulating voltage was 2.5, now they have increased the modulating voltage by 7.5, correct? Now AM value is 7.5. They are asking the delta F, calculate the new frequency deviation. Understood? So now back to the formula. If we want to calculate delta F, this was the formula I told you. Now delta F we want to calculate. For that we should know AM and we should know KF, right? But KF value changes. Let me write down this formula over here. KF is equal to delta F over AM. We need to calculate delta F, right? AM is 7.5, right? In the new case. For this we need KF. So now see what is the formula for KF, as if I'll calculate it from here, that is delta F is equal to KF into AM. Can I write it down like this? Okay. Now we need to calculate KF, then only we can get the value for delta F, right? KF is 2000, and how will you get KF? Delta F is how much? 5 into 10 raised to power 3. KF we need to calculate, and AM is 2.5, right? So from here KF will get it as 2. So delta F value is how much? 2 into 10, that is 20 kilohertz, correct? Now they are asking the modulation index for each case. So modulation index formula is delta F by FM. So for each case, for the new case, delta F by FM, delta F is how much? 20 FM they have given divided by 500, right? Now similarly for this one we can get modulation index for both the cases.